Welcome to the Dreamy Physicist. Tonight, your journey begins, not in the stars, but beneath your feet, where ancient heat sleeps and silent pressure builds, like the breath you forgot you were holding. Hi there. I'm so glad you're here. Let's take a slow, soft step together into a place where science hums quietly beneath forests, lakes, and meadows, where the earth, though still, is never truly at rest. Close your eyes. Feel the weight of the world, not above you, but gently churning below. You lie on your bed, but tonight your imagination lies elsewhere, on a field of moss, on a mountainside in late dusk, on a plain where wind rolls through tall grass, and the ground hums beneath you with a sound too low for ears, but not too quiet for bones. The earth feels solid. We build on it. We walk on it. We call it grounded for a reason. But what lies beneath it is more than stone. Deep, deep below the calm surface, the earth breathes, not in lungs, but in cycles of pressure and release, in heat that rises and rests, in magma that coils and crust that shifts, like a sleeper turning slowly in their bed. You may not hear it, you may not see it, but the earth has a heartbeat of its own. It pulses through molten rock and liquid fire, far below where roots grow or rivers carve. Imagine standing on a green meadow in Yellowstone. The wind is soft. Birdsong rings out in the quiet. And yet, beneath your feet, a chamber the size of mountains breathes slowly, invisibly, as if the earth itself is dreaming beneath a blanket of stone. That chamber is called a caldera, a word that means cauldron, a sunken memory of something vast. It was not always so quiet. Once, long ago, it roared. The ground broke, the sky turned dark, and the earth exhaled with the force of 100,000 bombs. But now, you wouldn't know it. Now, it rests. Now, it simmers. This isn't just about volcanoes. It's about supervolcanoes. And like most powerful things in nature, they do not look the part. There is no cone, no peak with smoke, no dragon's mouth of lava. They are flat. Why? Deceptively calm. Supervolcanoes don't announce themselves with a single mountain. They stretch for miles. Their strength lies in silence, their danger in size. They are the Earth's ancient lungs. They inhale slowly, pulling magma from deep within. And when they exhale, they reshape the world. But don't be afraid. Fear shrinks curiosity. And this story is not a warning. It's an invitation to understand, to wonder, to lie gently beside the hidden giants and listen to the slow language of stone. You are not fragile. You are made of earth too. Iron in your blood, carbon in your bones, calcium from ancient shells pressed into the stone that now forms your teeth. You are the earth, knowing itself in human form. So when we speak of what lies beneath, we are also speaking of what lies within. Close your eyes again. Imagine a layer of crust, thin as an apple's skin. That's where we live, on that delicate rind, floating on molten fruit. Beneath us is the mantle, thick, viscous, and alive with movement. It flows, not like water, but like syrup on a cold morning, slow, stubborn, persistent. And from this vast, hot ocean of rock, plumes rise, columns of heat, magma lifted like breath through cracks in the crust. Sometimes they form volcanoes, small peaks, eruptions, localized fire. But sometimes, once in many hundreds of thousands of years, that plume settles under a place that doesn't crack easily. Pressure builds, chambers form. The land above bulges, swells, lifts ever so slightly. It becomes a supervolcano, not overnight, but over centuries, millennia. Yellowstone is one such place, but it's not alone. There are others. Lake Toba in Indonesia, a sleeping scar, so vast became a lake. Taupo in New Zealand, a place so calm above, so chaotic below. We'll visit them in time, one by one. But first, you simply lie still. Let the idea settle. Let it breathe beside you. The ground beneath you is not just dirt. It is history. It is potential. It is deep time made real. And you are part of that story, a quiet observer on a planet that moves, even when it looks still. The earth is not violent by nature. It is rhythmic, and its rhythms are slow. Slower than your heartbeat, slower than a tree's growth, slower even than the shifting stars. To live on Earth is to live with things far older than fear. And under your cities, under your forests, under your sleeping body tonight, those ancient rhythms play on, not out of malice, not out of chaos, but because the planet, like you, must exhale. Not all volcanoes are alike, and not all eruptions are created equal. Some are brief, some are local, but some are so vast they change the sky. So how do you define super? By size? By silence? By the scars it leaves behind? Or by the way it reminds us, gently, firmly, that we are part of something deeper, something larger, older, and beautifully, breathtakingly alive? You'll carry that breath with you now, as we take one slow step deeper into the mystery and begin to ask not just where volcanoes are, but what makes them super. You ask now on the idea that not all volcanoes are shaped like cones or roar like dragons. Some do not rise, they sink. Their mouths are wide, their voices soft for centuries, their strength not in fire, but in silence. You've heard the word supervolcano, and perhaps your mind imagined something towering, terrible, impossible to miss. But no, a supervolcano does not demand attention. It waits, and in that waiting, it gathers its strength. So, what makes a volcano super? Not its height, not its shape, not its temperature. What makes a volcano super is the scale of its breath, its capacity to exhale with such force that the entire sky changes color. To be called a supervolcano, a single eruption must release at least 1,000 cubic kilometers of ash, gas, and molten rock. Try to picture it. That's enough to cover a continent in a soft gray blanket. enough to fill Lake Erie twice over, enough to darken the sun for weeks or months, not just over the volcano, but over entire hemispheres. It is not a firework. It is a curtain drawn across the sky. You might imagine a classic volcano, like Mount Fuji or Mount St. Helens, as powerful, and they are, but their eruptions, as dramatic as they seem, are tiny on the scale of what super means. St. Helens in 1980, a moment frozen in photos, in stories, in memory, released just one by 500 of the material a supervolcano could. If that eruption was a candle, a supervolcano would be a sun. But supervolcanoes do not erupt often. They are creatures of deep time. Their lifespans stretch far beyond human history. Their moments of awakening, rare and staggering. The last known supereruption was over 26,000 years ago at Lake Taupo in New Zealand. Before cities, before writing, before memory, the earth forgets quickly, but it also remembers deeply in the layers of ash and the shape of land and the whispers of gas still rising in the quiet. Supervolcanoes begin, as all volcanoes do, in the deep heat of the mantle. Hot plumes rise, like ghostly towers, pillars of soft fire pressing against the crust. Most volcanoes form a narrow channel and erupt through a vent, lava spilling, gases released, pressure eased. But a supervolcano is different. Its chamber is wide, its roof is heavy, and the pressure cannot find an easy escape. So it waits and builds, and the magma accumulates year by year, century by century, like steam behind a sealed door. This chamber, hidden deep within the earth, becomes a growing lung beneath a quiet forest, a calm lake, or a sprawling valley. At the surface, nothing seems unusual, but underground, it is a cathedral of molten stone. Pressure becomes tension. The crust above begins to bulge, so slowly you would never feel it. But satellite eyes can see the rise. They can watch the land lift, millimeter by millimeter, as if the earth is taking a breath and has not yet let it go. And then, sometimes, after thousands of years, the breath is released, not in a sigh, but in an exhale that breaks the world's stillness. The crust fractures, the chamber collapses, and all at once, the gases expand, the magma erupts, and the sky fills with fire and ash. In minutes, what was once a forest or plain becomes a caldera, a vast, sunken bowl carved by the violence of the planet's release. The effects are not local, they are planetary. Ash clouds climb 20, 30 kilometers high, far into the stratosphere, where winds carry them around the globe. The sun dims. The skies turn strange. And for months or years after, the climate cools. Temperatures drop. Crops fail. Rain falls less often or comes in torrents. It is called a volcanic winter, a season born not of snow, but of smoke. And yet, the earth recovers. Always. Eventually. But for those who live through it, the memory becomes myth. Once around 74,000 years ago, Lake Toba in Indonesia erupted. Some scientists believe that eruption dimmed the Earth's light so deeply, so long, that human populations dwindled, perhaps to just a few thousand. It is only a theory, but a powerful one, that we are all, every one of us, descended from the survivors of a long, gray year beneath a darkened sun. A supervolcano, then, is not just a geologic event. It is a fork in the story of life, sudden pause in the rhythm of things. But remember, these events are rare, exceptionally rare. So rare, in fact, that modern humans have never witnessed one firsthand. You live in a moment, between breaths, in a stillness that feels like forever, but is only a pause in the planet's rhythm. Still, scientists watch, satellites measure, sensors listen for the gentle shifting, the rising warmth, the quiet signs that magma is stirring far below. Not because we fear, but because we want to understand what the Earth is saying. So, what makes a volcano super? Not just size, but scale. Not just heat, but history. Not just eruption, but evolution. A long process of change, hidden beneath still soil. It is the story of quiet buildup, followed by sudden transformation. A reminder that slow things can still be powerful. That stillness is not the absence of motion, but sometimes its deepest preparation. Tonight, as you lie still, you are lying on a planet that breathes slowly, that dreams in magma, that writes its history in ash and stone. And beneath you, beneath the city, beneath the trees, beneath your own quiet room, there may be a chamber waiting, growing, rising drop by drop like candle wax in the warmth of time. What happens if it erupts? What would it feel like to live in the shadow of such a breath? That's what we'll wonder next as we step into the story of Yellowstone, where the earth sleeps on the edge of memory and every meadow holds a secret heat. Close your eyes and imagine a sky that forgets how to be blue. Not nightfall, not storm, but a strange and endless twilight in the middle of day, as if the sun itself had quietly turned away. Now picture this sky, not just above your home, but stretched over the whole of the earth, a hush laid across continents, the breath of a planet held in silence. This is no fantasy. It has happened before, and the earth remembers. Some disasters roar in with warning. Others begin in stillness. 74,000 years ago, in what is now northern Sumatra, a vast lake sleeps in a caldera, Lake Toba. But long before it was a lake, it was a mountain with a secret. Beneath it, for centuries, magma had gathered, slow and thick like honey pressed in darkness, waiting with quiet force beneath the crust. No earthquake gave it away. No animals fled. But one day, the pressure exceeded what the land could bear, and the mountain broke from the inside out. It wasn't a typical volcano, not a single peak spitting fire, not a lava stream trickling down. This was something deeper, wider, more complete. the land collapsed, a hole torn open in the fabric of the earth, and from it rose a column of ash, 50 kilometers high, reaching the stratosphere, piercing the sky with the breath of fire that had waited thousands of years to speak. Imagine it, a plume of ash and gas, towering taller than Everest, sailing beyond the clouds, carried by winds to every corner of the globe. And then the world began to darken. The ash didn't fall like snow. It fell like silence, a silence so heavy it blanketed forests, choked rivers, coated oceans in dust. Across Asia, across Africa, across the wide Pacific, fine particles of volcanic glass drifted through the atmosphere, scattering sunlight, muting color, cooling the warmth of every sunrise. This was not weather. This was something else, a volcanic winter. Temperatures dropped. Rain patterns shifted. The sun grew dim behind the haze. Photosynthesis slowed. Crops failed before crops were even planted. Plants died where they stood. And those who fed on plants, mammoths, deer, birds, and the early humans who hunted them, found themselves in a world where survival was not a birthright, but a daily prayer. Some scientists believe this darkening sky triggered what we now call the Toba bottleneck, a moment in deep human history when our population may have dwindled to fewer than 10,000 people, scattered, isolated, huddled in small bands across the continents. Entire branches of humanity lost in the cold. You carry in your genes the story of those few who survived, the children of fire and ash, whose eyes adjusted to the lightless days, whose bodies endured a world painted gray. No written record remains, no memory carved in stone, but we see it in the soil. We read it in the ice. A layer of ash traced across lake beds in India, volcanic glass buried deep beneath the African savanna, a sudden dip in global temperatures, etched in tree rings from a time long before clocks. And somewhere in those rings, somewhere in that ash, you feel a strange echo, a grief older than memory, a chill that touched the bones of your ancestors when the sky turned black. The eruption itself may have lasted days, but its shadow lingered for years. And when the sky finally cleared, what returned was not what had been. The forests were different. The animals changed, and the people who survived carried the mark of resilience and silence and wonder. Perhaps in that long darkness, language took root as families told stories by firelight, trying to explain what the sky had done. Perhaps myth was born. Gods of ash, spirits of fire, suns that vanish and only return if properly honored. Even now, we find ourselves drawn to these stories, the ones told in lava and silence. And we ask, could it happen again? Could another supervolcano breathe upward from the underworld? Is there another mountain gathering heat beneath our feet? These questions do not need to be answered tonight. There is comfort in knowing that Earth moves slowly, that such events are spaced by millennia. But there is wisdom 2. In listening for the breath beneath the stillness. Tonight, as you lie still beneath your soft roof of stars, know this: the sky has turned black before, and it may again, but always after the silence, after the ash, the earth remembers how to bloom, and somewhere beneath another ancient caldera, a lake sleeps where once the fire spoke. But not all fire has cooled, not all breath is done rising. And in the next moment, we will travel to one of the most closely watched places on Earth, where the land pulses quietly and scientists listen closely for every faint rumble. It sleeps, but not deeply and not without dreams. Beneath pine forests and turquoise springs, beneath the hooves of elk and the pads of wandering bears, a slumbering giant breathes in the dark. You know its name, Yellowstone. But names do not tame what lies beneath. They only help us whisper about it without trembling too much. By daylight, it looks like wonder, old faithful rising on schedule, as though the earth had learned punctuality. Geysers tossing steaming columns into sky blue air, pools of color that seem too beautiful to be made by heat and acid. You might stand at the rim of grand prismatic spring, watching the rainbow edge of its liquid eye, and think, how peaceful, how strange, how still. But underneath, everything moves. Yellowstone is no ordinary park. It is a caldera, a collapsed volcano scar, 45 miles wide, from rim to rim, sitting atop one of the largest magma reservoirs on Earth. It has erupted before, 3 times, with a force measured not in explosions, but in epochs. 2 million years ago, then 1.3 million, and again 640,000 years passed. Each time, the land cracked open, ash rode the winds, skies turned, and the world changed. Not just Wyoming, not just America, but the entire atmosphere, the oceans, the seasons, the shape of life itself. It is hard to picture such quiet land unleashing so much sky. But that was long ago. And now, it dreams, it shifts, it hums. Hundreds of tiny earthquakes, each year, none deadly, but none meaningless. Just little pulses, as though the earth were rolling over. In its sleep, scientists track them like heartbeats. They measure ground rise to the millimeter, watching for uplift, as if the land were inhaling. They peer deep with seismic waves, listening for magma stirring in its chamber. It is not danger they study, but possibility. And in possibility, there is always room for awe. Still, possibility carries weight. You might ask, what if it erupts again? What would happen if Yellowstone stopped dreaming and awoke? The answer is not simple, but the imagination is quick. First, the quake. The ground ruptures. The pressure, held for millennia, finds escape. Then the dome collapses, and ash begins its ascent, not from a single peak, but from fractures, a field of fire, opening like a terrible blossom. The column could stretch 15 miles into the stratosphere. Within hours, Ashfall would blanket Wyoming, then Montana, then the plains beyond. Airports close, cities dim. Midday takes on the color of dusk. The sun, a weak orange glow behind veils of dust. Ash is not just gray snow. It is sharp. It scratches lungs. It silts engines. It buries fields. But this is not just a local story. The ash rises high. It catches winds that cross oceans. It touches the Great Lakes, New York, London, and beyond ash, there is sulfur dioxide, released in waves, turns to aerosols. In the stratosphere, tiny mirrors reflecting sunlight back into the black. Temperatures fall, rain shifts, crops fail, not from heat, but from cold, from too much winter where summer should be. It happened before. Tambora, 1815. A different volcano, but the same song. A year without summer. Snow in June. Famine. Frostbitten harvests. Hunger on every continent. Yellowstone could do the same, or more. But fear not. The odds are in your favor. The chance of a Yellowstone eruption in your lifetime is less than 1 in 100,000 per year. And if it came, there would be signs, months, even years of stirring, swarms of quakes, round swelling, gas plumes, warnings enough for watches, for movement, for plans. Still, the earth does not run on human time. So we watch, and we wonder, and the giant it dreams on. Yet Yellowstone is not just risk. It is revelation. It is heat rising to meet water. It is pressure painting in color. The vivid rings of grand prismatic spring are drawn by life, bacteria, and archaea that live in boiling waters, thriving where most life would perish. It is a window into Earth's beginnings, what the world was before the air turned blue. It teaches us that danger and beauty often share the same ground, that stillness can be restless, and sleep can be watched. So when you walk the paths of Yellowstone, know you tread on warmth and memory. You walk over magma. You walk over time. And yet, the bison graze. The geysers breathe. And life continues with quiet trust in the slumber below. Because some giants dream in fire and do not wake until the world is ready to listen. And next, we journey back to the one that did awaken, the one whose breath darkened the sky, turned summer cold, and echoed through history's harvests. Let us travel now to Tambora, and the year the sky forgot warmth. You cannot hold a mountain in your hand. You cannot wrap your arms around a caldera. And yet, somehow, you try. To measure a volcano is not to tame it, but to understand its moods, its long silences, its quiet unrest. It begins not with rulers, but with listening. You kneel beside the earth and place your instruments, like a stethoscope, to a sleeping chest, wondering, is it dreaming again? The volcano is vast, but its signals are small. It whispers in seismic murmurs, little tremors beneath the soil. barely strong enough to stir a stone. And yet, when mapped over weeks, these tiny quakes become patterns. A cluster here, a swarm there, movement in the deep. Seismologists read them like pulses, measuring their frequency, their rhythm, their strength. Each shake a word in a language spoken by magma. But tremors alone don't tell the full tale. You need to see without eyes, to feel without touch. So you turn to the ground itself, to how it rises, so slowly, so subtly, that only satellites can sense its breath. It's called ground deformation. The earth lifts, tilts, bows outward, in slight bulges, millimeters at first, then centimeters. Like a sleeping lung, the land exhales, then waits, then stirs again. It's not always danger, but it is always movement. And movement means energy, and energy must go somewhere. Still, you want to go deeper. Not just how the ground moves, but what moves beneath it. Here, you borrow the earth's own voice. You send waves through stone. You measure how they echo. Seismic tomography, a kind of ultrasound for the underworld. It shows pockets of molten rock, zones of heat, chambers of possibility, not full lakes of lava, as stories often suggest, but sponge-like regions, part rock, part melt, part mystery. Each wave bends and bounces, telling you what lies below without breaking the surface. It is science, as deep listening, patient, precise, quiet. Then there is the breath of the volcano, its gases. Even in sleep, a volcano exhales. Through cracks, through fume rolls, through steaming pools. Sulfur dioxide, carbon dioxide, hydrogen sulfide. They rise invisibly, carried on wind. Scientists walk with sensors, send drones, set up monitoring stations. If the gases increase, if their ratios change, they whisper of magma rising, of heat drawing closer to the surface skin. The volcano tells you what it eats by the air it releases. And sometimes it starts to breathe faster. But there is more. The magnetic field, the gravity field, how rocks resist electricity. All of these shift subtly when molten rock gathers. So you learn to measure the invisible. You learn to find the fingerprint of fire buried in the earth. And you begin to see not just volcanoes, but personalities. Yellowstone rises and sighs. Etna pulses like a heartbeat. Tambora slumbers long, then wakes with fury. Each giant has its own rhythm, its own voice, its own way of sleeping. You might wonder, why? Why measure them so closely? Why peer into the breath of something that sleeps for tens of thousands of years? Because one day it may wake, and when it does, every minute of listening will matter. And even if it sleeps on, its dreams shape your world. Volcanoes make continents. They birth islands. They feed forests with their ash. The very air you breathe owes part of its birth to ancient eruptions. To measure a volcano is not to fear it, but to understand how deeply it is tied to everything you are. Think of the tools: a GPS unit buried in snow, a drone humming over a steaming vent, a satellite passing high above, taking pictures with no eyes. Together, they become an orchestra of observers. And the volcano, it plays a song, so slow, so low. Only the patient can hear it. You learn to read time in centuries. You learn to feel movement in the quiet. But there is humility too, because even with every tool, every station, every whisper caught and plotted on a screen, a volcano can still surprise. Mount St. Helens, 1980. Warnings came, but the sideways blast, unexpected. Nevado del Ruiz, 1985. A small eruption caused deadly lahars, mud flows racing down, carrying villages away. Science listens, but nature does not always speak clearly. So scientists don't promise. They watch, they warn, they prepare, and always they listen. You live in a world that sits gently on restless heat. Your continents float on molten breath. Your air was once inside the earth. To measure a volcano is to honor that truth. To say, we see you, we hear you, we are learning your language. And when the time comes, we will try to answer. But how do you know when that time is near? How do you separate restlessness from awakening? And what happens when the signs are clear, when magma truly rises and the mountain begins to open its throat? That's the question we follow next. To a time when the signs aligned, the ground swelled, and humanity faced the question, do we stay or do we flee? Come now into the shadow of a simmering peak where watching becomes warning and time runs thin. You lie down as the sky turns from blue to violet gray, your breath sinking with the evening air. Beneath you, the ground feels still, but it is not silent. Deep in the dark earth, far below roots and fossils and stone, magma shifts. It speaks, not in words, not in any language your ears were made for, but in pulses, heat, and slow, molten grammar. It has no mouth, but it has rhythm. It has intention. And if you listen long enough, you begin to hear it. Magma is more than molten rock. It is memory under pressure. The ancient earth, hot inheritance. It forms when rock melts in the furnace of the mantle where temperatures rise above 1,200 degrees Celsius and the weight of continents bears down from above. There, in that vast and buried ocean of stone, atoms loosen, crystals break apart, and solid becomes fluid light. But magma does not stay where it was born. It rises. It's buoyant, like a dream that refuses to stay buried. Lighter than the cold rock above, it begins to move upward, slowly, patiently, seeking cracks, faults, pathways. Sometimes it gathers in chambers beneath volcanoes, trapped, cooling, pressurizing. Other times, it continues its journey all the way to the surface. But even before it erupts, it speaks. And you, with your instruments, your measurements, your quiet curiosity, are learning how to listen. The language of magma is not spoken in words. It is spoken in signs. First, it heats the earth. Thermal sensors catch a sudden rise in temperature, a subtle fever beneath the forest floor. Then, gases change. Sulfur surges. Carbon dioxide escapes in greater plumes. The ratios between them begin to shift like changes in a voice just before it cries out. And then the earthquakes begin, not all at once, not with violence, but in clusters, swarms, a flurry of small tremors as magma presses upward, breaking through rock, nudging open ancient seams. Each quake is a syllable, each gas release, a breath, each bulge in the land, a pause before the next line. Together, they form a sentence, but reading it requires more than tools. It requires pattern, memory, context. Not all magma movement means eruption. Volcanoes have false starts. They murmur for months without a climax. So volcanologists gather history. They compare present signs to the past, to the years before Mount Pinatubo, before Mount Redoubt, before Vesuvius stirred. In AD 79, they ask, has this mountain spoken this way before? And if so, how loud did it become? It's a slow decoding, no easy dictionary, no straight line, from signal to certainty, because magma does not shout. It builds, it surges and stalls. It pretends to rest, then charges again. You must read between silences, between seismic whispers and chemical sighs. And when enough signs align, you know it is no longer dreaming. It is preparing. Still, there is wonder in its movement. A rising magma body is not just heat, it is transformation. It changes the rock through which it passes, melting it, fracturing it, mixing with it. It evolves, becomes more viscous, more volatile, sometimes more explosive. The more silica it holds, the stickier it becomes, like honey in a cold jar. It traps gases. It builds pressure until one day it must be released. That's when magma turns into lava, when underground pressure breaks the seal, when the earth's buried fire finally finds its voice. But there is a moment just before, a breath, a stillness, a lull, in which everything hangs, silent but trembling. That is the most delicate part of the language, the part you listen for with your whole body. Because when the magma stops speaking and begins to move, you have only hours, perhaps days, before the ground opens. And even then, no two volcanoes speak alike. Some erupt with fountains, like Hawaii's Kilauea, a steady stream of fire, flowing slowly, predictably, like breath. Others, like Krakatoa, like Mount St. Helens, erupt with violence, tearing open sky and sea, releasing the pressure all at once. The difference is in the chemistry, in the gas, in the way the magma holds its breath or lets it go. Some giants sigh, others scream. To measure a volcano is to know the difference. And still, beneath all this science, there is story. Because what is magma, if not memory, of Earth's early days, of collisions and chaos, of ancient heat that never died? You live on a thin shell. Beneath you, a furnace. And beneath that, heart that still beats with the rhythm of planetary birth. That is what magma reminds you of, that nothing ever truly cools, not completely, not forever. And so you continue to listen, to measure, to compare notes with colleagues across the world, all tuning in to the same slow song from beneath their feet. And when the patterns line up, when the voice grows clear, when the ground tightens and the gases flare, you begin to warn, not with panic, but with preparation, because the language of magma is not meant to frighten. It is meant to be heard, and heard in time, it can save. But what happens when we hear it too late? What if a mountain stirs in silence, hidden by snow or time or disbelief? What happens when people choose not to listen? That's where we go next, to a village that slept beneath a quiet peak, never knowing it had begun to whisper. You step outside into a memory of a season that should have been warm, but wasn't. The year is 1816, and the summer never comes. Snow falls in June. Crops fail. Birds vanish. People stare at a sky that feels wrong. The sun, once golden, now glows a dim and coppery red, its warmth veiled, its promise broken. The world, for one long year, shivers in silence, and no one knows why. You breathe in the chill of that forgotten summer, a time before satellites, before seismographs, before warning systems, a time when the sky darkened and no one understood. But now, centuries later, you do. Now you know. The sky went dark because a mountain exploded. Far away, on the other side of the earth, a colossus named Tambora awoke from its centuries of sleep. Tambora sat quietly on the island of Sumbawa in the Dutch East Indies, a volcanic giant 3 miles high, lush and green, blanketed with forests and villages and unaware lives. It had been sleeping for over 1,000 years. And then, in 1815, it stirred. The ground trembled, faint at first, then stronger. Ash drifted like snowflakes, then fell like rain, then poured like night. People thought it would pass, but the mountain had just begun. On April 10th, 1815, the world heard the loudest sound ever recorded by human ears. Thunderclap that echoed 2,000 kilometers away. Sailors at sea thought they were under attack. People in Jakarta thought war had come. But it wasn't cannon fire. It was the sky breaking open. Tambora had erupted, not with lava, but with force, with a violence rare in all of history. It wasn't just a mountain letting go. It was the earth exhaling centuries of silence in one terrible breath. The eruption threw ash 30 miles into the sky. A column so tall it reached the stratosphere, where jet streams spread it like a shroud around the globe. Gas met sunlight, ash met air currents, and the earth began to change. At first, it seemed like a distant event, but then the sky dimmed in places thousands of miles away. China lost its summer harvest. India was swept by cholera. And in North America, your body would remember it as the year without a summer. Snow fell in Vermont in July. The lakes froze in Pennsylvania. Frost killed the corn before it ever ripened. And hungry people slaughtered their last animals because nothing would grow. There were no sunsets, only bruised skies, a blood-orange moon that never brightened the night, days that looked like twilight, nights that pressed too long on the mind. And poets wrote by candlelight about the end of the world. Even Mary Shelley, curled in a cold villa beside a Swiss lake, felt the ash in her lungs. She wrote stories of monsters born in lightning. And you wonder, did Tambora create Frankenstein too? Because sometimes, when the air grows strange, the imagination listens. But this isn't just a story of fear. It is a story of connection. Because Tambora's eruption didn't just end lives, it linked them. One mountain on one island reshaped the sky over half the world. Its gases, mostly sulfur dioxide, reacted in the upper atmosphere, forming aerosols that scattered sunlight back into space. The Earth cooled by nearly a full degree. That may sound small, but it was enough to rewrite weather patterns, to shrink growing seasons, to shift winds, and starve millions. This is what a supervolcano does. Even if Tambora wasn't quite one of them, it reminds you how thin the veil is between ordinary life and planetary change. Volcanic winter, that's what scientists now call it. Season stolen, a world under shadow, not because of war, not because of human fault, but because the earth spoke loudly, and we didn't know how to hear it yet. You imagine waking each morning in a world where the sun no longer warms you, where smoke hangs in the trees, where every animal looks thinner than it did last week, where every child's eyes ask questions no one can answer. You imagine hearing the stories that the sky is broken, that God is angry, that the seasons are ending. Because when the science is missing, myth takes its place. And in 1816, myth was all they had. But now you have more. Now you have satellites to watch the ash, infrared sensors to track the gas, historical records to trace the trembling past. And so you understand what they could not. You understand that one eruption can shift everything, that the world is small enough to be cooled by a single breath from deep within the earth, and that a true supervolcano, like the one sleeping beneath Yellowstone, could do even more. You turn back to the present. The skies are clear. The sun is warm again. But the memory lingers. in old journals, in tree rings, in ice cores that still hold Tambora's signature. And in those cold, silent clues, you read a warning. It has happened before, and it could happen again. But can we see it coming? Can we hear the mountains whisper before it turns to thunder? In the next chapter, you'll stand among sensors, drones, and watchtowers and learn how scientists try to catch the sky before it falls. You trace your finger along the edge of the Pacific, from the tip of South America, up the Andes, through Mexico, curling into the Rockies, then across Alaska, down through Japan, Indonesia, the Philippines, and New Zealand. A trembling necklace, a path of fire. The Pacific Ocean is quiet on the surface. Its waves roll gently. Its vastness feels eternal. But beneath it, a restless story unfolds. You're standing now on the rim of the Ring of Fire, and it is alive. The Ring of Fire is not made of fire. It is made of edges, of plates that press, grind, and subduct beneath one another. You picture them, gigantic slabs of Earth's crust floating on the hot mantle, like cracked ice on a slow-moving river. But these slabs, called tectonic plates, don't drift gently. They push. They crash. They dive beneath each other in deep trenches where the sea floor falls away, and where one plate sinks, another rises. You walk the arc with your mind. Along it lie more than 450 volcanoes, 75% of all volcanoes on land. You feel the slow pulse beneath your feet as magma forms in the spaces where the plates descend. You see the boiling edge of one world slipping under another. That is where volcanoes are born, in zones of subduction, where pressure melts rock into fire, and fire presses upward through stone. It is here, in the Ring of Fire, that most of the Earth's greatest eruptions have been staged. Not just Tambora, but Krakatoa, Mount St. Helens, Pinatubo, Tofua, Taupo. You stand at the hem of a robe woven in destruction and rebirth, because fire is not just an end, it is also a beginning. Subduction zones are also places of creation. As oceanic plates dive beneath continents, they feed the volcanoes above. Each eruption lays down new land. Ash becomes soil. Lava cools into rock that will someday become mountains. This is how the Andes rose. This is how Japan was shaped. This is how islands like Tonga and Samoa emerged from sea and steam. Volcanoes are destroyers, yes, but they are also architects. They sculpt the earth from below. But the Ring of Fire, as kin, it is not the only arc that holds the earth's breath. You drift now toward Iceland, where fire and ice live side by side. Here, volcanoes emerge, not from subduction, but from separation. Iceland straddles a mid-ocean ridge, a place where plates pull apart instead of collide, and as they part, magma wells up to fill the gap. It's quieter here, more constant, but still very much alive. You remember the 2010 eruption of Eyjafjallajökull, a name that danced on foreign tongues and grounded plains across Europe. A small volcano, yet its ash found the sky, found the jet streams, and the world, once again, was reminded that the earth beneath us does not sleep quietly. Even distant voices can echo far. Then you travel south to Africa, to the East African Rift, where the continent itself is tearing slowly apart. There too, fire follows fracture. It bubbles up in lakes and cracks, in steam vents and lava fields that stretch through Ethiopia, Kenya, Tanzania. Someday, this rift may birth a new ocean. Someday, the land will split and fire will fill the divide. Each of these regions, the ring of fire, the rift valleys, the mid-ocean ridges, tells you something profound. That Earth is not still, that your world floats on a sea of stone that moves inch by inch, age by age, that volcanoes are not scattered randomly, but follow the hidden skeleton of the earth. And it humbles you to know that beneath cities, beneath oceans, beneath quiet hills, the plates are always shifting. To know that continents ride on currents of hot rock that churned like breath beneath a sleeping chest, and that breath, once held too long, erupts, sometimes with warning, sometimes without, but always from a deeper rhythm than we can see. You sit with this knowledge. Let it settle. The ring of fire encircles more than just the Pacific. It encircles your sense of permanence. It reminds you that mountains can rise in a single day, that islands can vanish beneath waves they themselves create. And yet, you remain. You live on a world that reshapes itself while you dream. You build lives on lava fields, plant gardens in ash, write poems in the shadow of peaks that could roar at any time. Why do we stay? Why do we live so close to danger? Because volcanoes also give. They give soil rich with minerals. They give hot springs and geothermal warmth. They give landscapes that awe and inspire. And perhaps they give something else, a sense that we are small, but not alone, that we are part of a living world, still writing itself beneath our feet. As you lie back, the map of the earth glows gently in your mind. You see the scars and seams. You see the arcs and ridges. And you feel a quiet pulse running through it all. The earth speaks in magma, in ash, in tremors you barely feel. And now you know how to listen. But can we measure that voice? Can we learn its rhythms? Translate its signals before the next eruption? In the next chapter, you'll follow the scientists who try to do just that, who track the murmurs and measure the giants. You stand at the rim of a vast, silent bowl, a crater carved not by time, but by violence. The earth is quiet now, but here in this sunken hollow. It once shouted. You feel it in the wind, in the way dust settles on fractured rock. Something happened here. Something so immense. It left a scar that will never heal. This is how volcanoes remember, with craters, with layers, with hidden clues pressed into ash and stone. You crouch, running your fingers along a wall of cooled lava. To you, it feels ancient, but to Earth, it is recent breath. You're not just looking at a hole in the ground. You're reading a story. Every crater has a history written not in words, but in waves of destruction. A supervolcano, when it erupts, doesn't just spit fire from a mountaintop. It empties its heart. Its underground chamber collapses inward, leaving behind a caldera, a sunken field, sometimes miles across, flat, broad, like the bottom of a drained sea. Some craters hide in plain sight. They are mistaken for valleys, meadows, even lakes. Yellowstone's vast basin, green and lush, is a caldera formed when the Earth's crust gave way beneath its own fury. Long Valley in California, Lake Toba in Indonesia, Taupo in New Zealand, all calderas, all reminders of past awakenings, like sleeping giants whose breath still warms the ground. But we don't just study the shape, we dig deeper, literally. Volcanologists, those who listen to the Earth's whispers, read its memory layer by layer. In ash deposits, they count time backwards, each layer a page in the planet's diary. Light ash, dark ash, pumice, so light it floats on water. Obsidian, glass born of flame. They map the chemistry of each eruption, what minerals were melted, what gases were trapped, what temperatures raged below. It's like reconstructing a firestorm from the pattern of the ashes. Then there are the crystals, tiny, glimmering timekeepers within the rock. They form as magma cools, growing slowly, trapping secrets inside their structure. Zircons, for example, can hold radioactive clocks that tick in silence for millions of years. By reading them, scientists know when magma last moved, how long it sat underground, and when it might grow restless again. Each eruption leaves behind these silent witnesses. Each crater is a vault of time, and sometimes the clues lie far from the crater itself. Ash from ancient eruptions has been found thousands of miles away, buried in Greenland's ice or locked in the seafloor. Imagine. So vast that it circled the globe. Its dust settled slowly onto continents it never touched. This is how we know Tambora erupted in 1815, darkening skies and chilling summers as far as Europe. This is how we know Yellowstone's last eruption spread ash from California to the Mississippi River. The earth remembers in layers, in soot, in silence. We also look for ground that breathes. Using satellites, scientists track how the earth rises and falls, a quiet inflation, a swelling of land itself. This is the magma pressing upward, searching for a way out. In Yellowstone, the ground can rise more than an inch in a single year. In Campi Flegrei, the restless fields near Naples, the earth has lifted and dropped like lungs for decades. These movements don't guarantee an eruption, but they whisper of motion beneath. Then there are the gases, volcanoes, even dormant ones, exhale carbon dioxide, sulfur dioxide, steam. Sometimes these gases seep through soil, into trees, into lakes. Sometimes they're deadly. At Lake Nyos in Cameroon, a cloud of carbon dioxide suddenly surged from the water, silently suffocating an entire village. We monitor these emissions to detect pressure, to listen for warning. Even breath can be a clue. Still, not all signs are easy to read. Sometimes a volcano will tremble for years, send gas, lift its land, then nothing. And sometimes a quiet crater erupts with barely a hint. The clues are there, but they are not always clear. The earth speaks in a language we're still learning, a dialect of heat and chemistry, motion and memory. We are translating slowly, page by page, and we are not only listening to the ground beneath us, but to the skies above. In space, satellites trace thermal signatures, measure bulges and gas trails. They turn volcanoes into pixels, patterns, charts. Technology gives us a long gaze, but not a perfect one. We are learning to see more, but not always to predict. Not yet. Still, there is wonder in the search, to hold a fragment of obsidian and feel the cooled rage of earth, to kneel in the shadow of a crater and know it once roared like the sky was splitting, to read in crystals and ash the long breath of a planet that dreams in eruptions, and to realize we are part of this ancient conversation. We walk on ground that remembers everything. The crater beneath you is quiet now, but you feel the hush that follows, a story half told, each layer a sentence, each deposit a word. There are more clues to follow, buried not in ash, but in sound, because before a volcano erupts in fire, it often trembles with soundless quakes. In the next chapter, you'll learn how the earth shudders before it speaks. Your life spans decades. The earth's life spans eons. And yet, you live on its surface, walk its shifting crust, breathe the air, born from its deep heart. It's easy to forget that time, as you know it, is a blink in Earth's memory. You mark birthdays, generations, centuries. But the planet, it moves to rhythms measured in millions of years, in plates drifting, in mountains rising, in magma cooling, beneath fields that seem forever still. Let's begin with your sense of time. You wake, you sleep, you mark a year by seasons, leaves falling, flowers opening, the gentle turning of your orbit around the sun. Human history, from cave paintings to cathedrals, from empires to electricity, stretches back only around 10,000 years. Agriculture, written language, cities, philosophy, rockets. It feels long when seen from the lens of culture. But if the Earth's age were a 24-hour clock, humans have been here for less than 1 second before midnight. You are new here, so very new. Earth is 4.5 billion years old. At first, it was molten chaos, a churning ocean of magma and metal smashed by asteroids, steaming with wild gases. Then came cooling. The crust hardened, seas condensed, life emerged in single cells, so small, so patient. For most of Earth's story, there were no trees, no dinosaurs, no songs, no stone tools, just microbial breath changing the air. Oxygen appeared slowly, land greened slowly. Shells, fins, forests, each took an age to arrive. And still, the Earth waited. Volcanoes have always been here. Not enemies, but sculptors. They built islands. They nourished soil. They sparked extinctions and rebirth. The largest ones, the supervolcanoes, erupt rarely, but leave marks that stretch across epochs. Take the eruption of Lake Toba roughly 74,000 years ago. It may have darkened the skies for years. Some scientists believe it cooled the Earth, shrinking populations, challenging early humans to adapt or perish. Imagine your ancestors huddled beneath ashen skies, watching animals vanish, rivers freeze. The Earth had shifted again, and time, for them, was survival. Even Yellowstone, so peaceful now, has erupted 3 times in the past 2.1 million years. That sounds ancient to you. To the Earth, its recent breath, the last major eruption, was about 640,000 years ago. Since then, your species has risen, drawn lines on maps, invented clocks, but the ground beneath has simply waited as glaciers came and went, waited as continents realigned, waited as humans built and forgot. What is 640,000 years to a crust that has shifted for billions? We measure volcanoes in cycles, not in calendars. We look to repose time, the quiet between eruptions. For supervolcanoes, this can mean hundreds of thousands of years. But humans often forget to think that wide. You want to know, will it erupt in your lifetime? But the better question is, where are we in its rhythm? Because the Earth doesn't rush. It prepares in silence, builds in deep chambers, breathes slowly through fractures and faults. And sometimes, without warning, it speaks. We build cities in calderas. We bathe in hot springs, fed by magma. We marvel at geysers and fumaroles. We forget that beneath the warmth is molten fire. And it's not recklessness, it's rhythm. Generations pass without eruption. And so, danger fades from memory. The earth remembers in rock, in pressure, in time, so large it makes our lifetimes feel like sparks in a long night. Consider this: the same volcano can sleep longer than your species has existed. And when it wakes, it doesn't care for borders or plans. The ash will fall on cities and farms, on old mountains and new roads. It will carry time backward, resetting what once stood. It's not punishment, it's pattern. And in that pattern, there is both danger and beauty, because out of the ash comes fertile soil, out of fire comes life. The planet reshapes, and new species emerge from the rubble, including once. So, how do we live on such a planet? With humility, with listening, with awe. We walk atop thin plates of crust, floating on slow currents of hot stone. And we measure time, not just in minutes, but in movements, in uplift, in tremors, in the gentle heaving of ground we call home. We are guests on a restless world, and that doesn't make life fragile. It makes it miraculous. To know the Earth's timeline is to step outside your own, to see that the sky has darkened before, that forests have returned after flame, that life always seeks its shape again. You are a part of that seeking, a moment in a longer becoming. You carry within you molecules forged in fire, atoms older than the mountains that shelter you. The earth shaped you, not just where you stand, but what you are. And so, when you think of supervolcanoes, don't think only of fear. Think of cycles, of the deep breath, of stone, of time that holds both endings and beginnings. We are temporary, yeah, but not insignificant. Our curiosity lets us peer into magma chambers. Our science lets us read the planet's diary. We are the first species to understand our own fragility against Earth's scale, and maybe the first to protect life from what it cannot stop. The Earth continues its quiet turn. Below you, magma shifts like thoughts beneath a dreaming mind. Above you, stars keep time far slower still. And as you rest on this ancient crust, remember, you belong to both timelines, the fleeting and the eternal. And when we study the rhythms of ancient eruptions, we are also asking something very human. What happens next? Because even after eruptions, after skies turn dark, light finds its way back. And in the next chapter, you will stand inside a volcanic winter and ask how the world begins again. The air is still, not because it's calm, but because it's empty. After the eruption, after the blackened sky, after the trees have bowed beneath ash, and the birds have vanished into silence, you are left with an eerie hush. It's not just sound that's gone. It's the familiar hum of the living world. But stillness is not the end. It is the pause before becoming. You stand in the gray, mountains in the distance, where veils of smoke. The soil beneath your feet is warm, light, loose. It crumbles like memory. The blast took what once stood: forests, fields, streams full of fish. It left behind craters, cracks, and silence. Yet even here, life waits in the ashes. It always does. In the hours after a supervolcano erupts, there seems wounded. The skies remain dark. Sunlight filters through like whispers through thick curtains. Temperatures fall. Crops fail. Rains change their patterns. It's what scientists call a volcanic winter, a chill that follows the heat of eruption. For months, sometimes years, global temperatures dip. It feels as if the world has forgotten how to grow. But something else is happening beneath. The land is resetting. After Mount Pinatubo erupted in 1991, global temperatures dropped by nearly half a degree Celsius. That may seem small, but to the Earth, it's enormous. Ash rose, more than 30 kilometers high, reaching the stratosphere, where sulfur dioxide transformed into droplets of sulfuric acid, a veil, reflecting sunlight back into space. And yet, even as the sky cooled, even as sunlight dimmed, something extraordinary began at ground level. The first green sprouted just weeks after the ash fell. It's easy to assume a volcanic landscape is lifeless, but in truth, it is possibility. Ash may bury, but it also feeds. It is rich with minerals, potassium, phosphorus, calcium, the silent elements that roots crave. And rain, when it comes, doesn't just wash away, it awakens. It carves gentle grooves through the ash. It sinks, carrying nutrients deeper into the earth. Seeds, buried in darkness, begin to stir. Sometimes, the first life after the blast is not what you'd expect. It's moss, or ferns, or tiny bacteria that feed on sulfur and heat. These early pioneers prepare the land. They crack the hardened layers, soften them, make way for larger forms. Next come grasses, then shrubs, then trees. But it takes time, years, decades. The earth is in no rush. Mount St. Helens. In 1980, it unleashed a lateral blast that flattened hundreds of square miles. It looked like a war zone, scorched, gray, dead. But researchers watched, year by year, as life returned. Pocket gophers burrowed through the ash, mixing soil. Lupins flowered, fixing nitrogen into the ruined ground. Beetles returned. Birds followed. Each arrival made space for the next. It became a living lesson that even in devastation, nature writes a sequel. And it's not just plants and animals that return. Humans, too, come back. In Indonesia, villagers live on the slopes of Mount Merapi despite frequent eruptions. Why? Because the land is fertile. Rice grows where ash once fell. Bananas, coconuts, cassava, they thrive in volcanic soil. The danger is real. But so is the gift. We are drawn to the promise of rebirth. There's a word for landscapes that bloom after fire. Succession. It means a sequence of return, of growth, of interwoven arrivals. One form of life makes way for another. Each stage heals the wound a little more, and slowly what was gray turns green. What was silent fills again with wings, with footsteps, with song. Even at Yellowstone, which hasn't erupted for over 600,000 years, we see evidence of past recoveries. The giant caldera now holds forests, rivers, meadows of bison. It doesn't feel like the remnant of catastrophe. It feels alive because it is. That's what the earth does. It reclaims, it rebuilds, it remembers how to live. And maybe that's the deeper story beneath volcanoes. Not just the power to destroy, but the patience to begin again. Every eruption is a kind of punctuation, and then that hints at a new start. It teaches you to see time differently, not as a straight line, but a cycle, not as loss, but as transformation. You begin to understand that even devastation can be a doorway, and you, standing in the soft ash, are part of this story. You too have known eruption, moment when everything changed, when what was known was buried under something sudden. But like the land, you hold the memory of growth. You are capable of starting again, not in spite of the fire, but because of it. So next time you see a volcano, don't just see the summit. See the seed hidden in ash. See the forest that will come. See the quiet between the pulses. And remember, life is not a line. It is a spiral, rising through time. The world continues, slowly, quietly, to unfold. Even the ground beneath your feet is healing. And ahead, in the next chapter, we'll return to the restless places, to the fire still stirring. Ask, what does it mean to listen to a volcano before it speaks? You walk a trail woven with mist and memory. The mountain is quiet today, a soft hush in the air, a kind of deep listening. But you know now, silence is never empty. It holds signs. And before the earth speaks, it always whispers. Volcanoes do not erupt without warning. Even when they seem sudden, the build-up is long and slow. Attention drawn tight beneath stone. To most, it appears peaceful. Still forests, snowy peaks, blue skies. But beneath it all, magma moves. It shifts, presses, seeks a path, and the earth, in its own strange language, begins to send signals. A volcano's warning signs are soft at first, like a sleeper turning gently in bed. The ground may swell just a little, arise, barely the width of your fingernail. Gas may hiss from ancient vents, invisible plumes of sulfur and carbon dioxide sneaking into the air. And deep below, earthquakes flicker, tiny tremors, like the mountain dreaming with twitching fingers. Volcanologists Those who listen to sleeping giants are the translators of these whispers. They plant their instruments like ears in the dirt, seismometers, tilt meters, gas sensors, thermal cameras, each one tuned to a different kind of breath. And together, they tell a story. You pause at the edge of an old crater. Once, this place roared. Now, birds fly overhead and wildflowers bloom where fire once bloomed. Still, scientists return here again and again, watching, waiting, measuring, because change rarely announces itself in shouts. It begins with a pulse. One of the clearest signals is ground deformation. Imagine the Earth as a great balloon beneath your feet. As magma rises, it inflates the crust just a little, just enough to change the shape of a hill or the curve of a valley. Satellites now scan this swelling from space. Even a few millimeters can be noticed, mapped, understood. To you, it looks unchanged. To the instruments, the mountain is breathing. Then there are the quakes, not the large, cracking kind, not yet, but small ones. They ripple through the rock like whispers behind walls. They come in clusters, swarming, dozens, hundreds, sometimes thousands in a single week. It's as if the earth is shifting in its sleep. The pressure below becomes restless. Crystals move, gas expands, and the faults, those deep seams in the crust, begin to feel the strain. Gas is another voice of the volcano. It bubbles from hot springs, vent, fumaroles, carrying secrets from the deep. Scientists collect it carefully, test its makeup. Sudden spike in sulfur dioxide, for instance, can mean magma is rising closer to the surface. Even changes in carbon dioxide or water vapor matter. Together, they form a pattern, a sentence, in a language millions of years old. Thermal signals come to a mountain may not erupt yet, but it heats. Subtle increases in surface temperature, especially near vents, suggest that something is stirring, like a fever before the sickness, like warmth before the wave. The key is pattern. A volcano doesn't erupt because one signal changes. It erupts when many change together. Rising quakes, growing gas, shifting ground, like instruments joining in a slow crescendo. Each warning builds on the last. Each breath draws closer to voice. But here's the great challenge. Every volcano has its own rhythm, its own silence, its own storm. What looks urgent in one may be ordinary in another. Some rumble for decades and never erupt. Others speak for only days before letting go. Scientists must learn the history of each mountain, its moods, its tempo. And even then, certainty is rare. The earth guards its surprises. Sometimes the signs are missed. In 1985, Nevado del Ruiz in Colombia showed many of them. Quakes, gas, steam, But on the day the eruption came, few were prepared. Lahars, mud flows of ash and melted ice, rushed down the slopes at terrifying speed. The town of Armero was buried. Over 20,000 lives lost in a single night. The silence had broken, but the world was not listening closely enough. That is why, in modern times, scientists work together. Networks of global observatories, 24-hour monitoring, communication systems ready to warn communities at risk, because signs are only as useful as our ability to hear them and to act. So what does it mean to truly listen to a volcano? It means watching what shifts when no one else notices. It means asking what the mountain is feeling, not just now, but across centuries. It means humility, knowing we don't control the fire beneath us, but we can learn its rhythms. It means respect, not fear, but understanding. You reach the summit now. The wind is cool. The ground is firm. But your eyes know what lies beneath. A cauldron, slow and ancient, always waiting. And your ears, in some quiet way, have learned to listen too. Not just for the blast, but for the tremble. Not just for the roar, but for the breath. In the next chapter, you'll walk even deeper into the systems humans build to understand what they cannot stop, into the tools, the warnings, the ways we speak to one another when the earth clears its throat, and the question will linger. Can we hear enough, soon enough, to keep each other safe before the silence finally breaks? You lie back beneath a dark ceiling of stars. The earth is still tonight, cool, hushed, as if the world has taken a long, slow breath. And somewhere inside you, a question stirs. Could it happen again? Could the fire beneath our feet rise once more? Unexpected, unstoppable? History says yes. The earth remembers everything. And you, quietly listening now, are part of that memory too. Volcanoes are not just past. They are present. They are patient. Time, to them, is measured in stone, in pressure, in pauses that stretch across generations. But they do not forget how to erupt. They wait, and the waiting is not sleep. It is readiness. Across the planet, more than 1,500 volcanoes are known to be active. Some, like Etna or Stromboli, grumble often. Small eruptions, fireworks on the landscape. Others, like Yellowstone or Toba, rest beneath parks and lakes, quiet for thousands of years. Yet, silence is not safety. Stillness is not peace. The earth is always moving. The magma is always there. You think back to earlier chapters, to ash that dimmed the sun, to lakes that boiled, to forests turned to fields of black glass. Those were not stories from myth or fiction. They happened, and they shaped everything that came after. The trees regrew, the skies cleared, but the memory remained beneath the soil. The question, then, is not if, but when. Could another super eruption truly occur? In your lifetime? Perhaps. Perhaps not. But the planet moves on its own timeline. It does not tick to the pace of human history. Super eruption, like the one at Toba 74,000 years ago, comes maybe once every 100,000 years. Rare, but not impossible. And in geologic time, we are always in the middle of a countdown. Even smaller eruptions can remake the world. In 1815, Mount Tambora in Indonesia blew with such force that 90,000 lives were lost. The ash cloud circled the globe. Crops failed. Horses died. People starved in lands thousands of miles away. It was the year without a summer, not a supervolcano, but close. And no satellites watched the sky. No early warning systems spoke. Today, we would see it coming. Maybe. We hope. The question, could it happen again? Has two parts. One is science. The other is preparation. The first is simple. Yes, the Earth still holds the ingredients. Magma chambers beneath Yellowstone, long fault lines near Naples, rumbling cones in the Pacific Ring of Fire. And each year, hundreds of eruptions remind us that the crust is thin and the furnace is full. The second part, are we ready, is harder to answer. We've learned much. We monitor more. We share alerts across oceans. We build maps of danger zones. And yet, a supervolcano would challenge even the best systems. Planes grounded, supply chains broken, power grids tested, skies filled with ash for months. The threat would be global, and it would begin, as it always does, with a whisper. Some scientists build simulations. They imagine the next big eruption. They model where the ash would fall, how the wind would carry it, how much sunlight would be lost. They try to predict the food shortages, the shifts in weather, the ways our systems might fail. It's not fear-mongering. It's listening. It's learning from the last time. Because if it happened before, without satellites, without sensors, then now, with all our tools, we owe it to ourselves to prepare. The truth is, we don't need certainty to be careful. We don't need panic to be wise. In Iceland, for instance, volcanoes are part of life. Roads are rerouted, homes evacuated, airlines adjusted. The people know the signs. They trust the science. They do not ask if as often as how soon. They live with the rhythm of fire, not fearing it, but understanding it. And that, perhaps, is the best answer to your question. Could it happen again? Yes. But it doesn't mean you should live in dread. It means you live aware that beneath the still crust lies a wild and ancient breath, aware that the earth, for all its beauty, is alive, and anything alive can surprise us. In a way, asking the question connects you to something larger, to the forests that once turned ash, then regrew, to the people who once watched the black sky fall, then farmed again. in the cooled soil, to the stars above and the magma below, both pulsing with mystery. We are brief guests on this planet, but we are learning to listen better, to plan better, to imagine how to stay when the ground shifts. And perhaps, most important of all, we're learning that change, even violent change, is not the end. It's part of the cycle. The earth clears, the dust settles, the seeds bloom. We begin again. But before the ground shakes, before the ash falls, there is still time to prepare, to share, to stay awake to the signs. And in the next chapter, you'll see how we try, how our early warning systems, our science, and our stories are becoming the lanterns we light against the unknown, because the silence always ends. And when it does, will we be ready to answer? Tonight, as your body settles and your breath softens, imagine a map glowing softly in the dark. Not a map of borders or roads or names, but a deeper kind, etched in ancient fire, in silence, in slow pressure, gathering far below. You're drifting now, above that glowing world, watching from above as sleeping giants stir quietly beneath the crust. These are the supervolcanoes, enormous, hidden, waiting, not scattered at random, but forming a quiet constellation across continents and oceans. Let's visit them together. Let's listen to their long dreams. You begin with a name already whispered in this series: Yellowstone, in the heart of North America, beneath the steaming geysers and gentle herds of bison, lies a massive chamber of molten rock, one of the largest in the world. It last erupted 640,000 years ago, and again before that, and again before that, each time reshaping the land in a violent breath that reached the skies. Today, we walk its caldera without knowing. We stand inside a sleeping giant's mouth. But Yellowstone is not alone. Far across the ocean, deep in Indonesia, lies Lake Toba, still serene, a mirror of blue ringed with green. But Toba, too, was once a roaring wound. Around 74,000 years ago, it erupted with such force that it filled the skies with ash for years, blotting out the sun, cooling the planet, shrinking populations. Some say humanity was nearly erased. Now, birds skim its surface, villagers fish its waters, but the caldera remains, a bowl wide enough to hold memory and silence and warning. Travel next to New Zealand, to the Taupo volcanic zone. Here, the earth is thin, alive with steam and color. Taupo itself last erupted around 1,800 years ago, a colossal blast that scattered ash across the Pacific, seen in skies from China to Rome. The crater has become Lake Taupo, vast, gentle, like a breath taken after grief. And yet beneath that calm still swirls an engine of pressure and heat. Next, we float northward toward the vastness of Russia. Here lies the Kamchatka Peninsula, and buried deep within it, the Karamshina caldera, a quieter name, less known, but mighty. The region breathes steam and magma, a wild mix of volcanoes and faults. This land is remote, but not forgotten. It hums with energy beneath its frozen skin. South again now, to the high shoulders of the Andes. Here we find La Garita, in what is now Colorado, a relic from 27 million years ago. Its eruption was one of the largest ever known on Earth, thousands of times larger than Mount St. Helens. You see no volcano now, just plateaus, carved cliffs, and rock that holds the echo of that roar. Even silence leaves fingerprints. Further south in the Andes, you reach Cerro Galen. In Argentina, a supervolcano so vast that its scale can only be seen from the sky. The people nearby live quietly, tending sheep, walking the land, as if unaware of the sleeping dragon beneath their boots. But science sees, and it remembers. From South America, across the sea, to Africa's rift, to Ethiopia, where the Earth's crust is stretching thin, tearing slowly. Beneath the Danakil Depression, beneath the Afar Triangle, scientists suspect a supervolcano could form. Not now, not tomorrow, but someday. It is not only about what has happened, but what is still becoming. Some giants have not yet awakened. Some are still being born. You pause above Italy, where history and myth blend with magma. Though Campi Flegrei is not as vast as Yellowstone or Toba, its eruption potential has drawn modernize. This caldera, near Naples, breathes sulfur and shakes gently in its sleep. In Roman times, it was called the Fields of Fire, and even now, evacuation plans lie ready. The giant may be smaller, but the cities above are many. Risk is not only a matter of size, it's proximity. All across the world, supervolcanoes wait in their own way. Some show signs, bulging ground, earthquakes, gas release. Others are quieter, their stories locked in rock, too deep to hear. We study them with satellites, seismic maps, chemical traces. We imagine how the sky would look if one erupted tomorrow. We ask, not in fear, but in curiosity. What would we do? What would change? These supervolcanoes are not like the classic cones you see in textbooks. They are not neat triangles. They are collapsed basins, craters filled with lakes, mountains turned inside out. They are the scars left by something vast, something beyond ordinary scale. And yet, they are natural. They are the Earth's way of cooling itself, of balancing pressure, of moving heat from deep within to the surface. They are terrible, yes, but they are also part of the planet's breath. And you, listening now, are part of that breath, too. You live above this slow, silent clockwork, this network of fire beneath stone, and still the surface holds so much beauty. Birdsong, snowfall, lakes that shine in ancient calderas, villages that dance on volcanic soil. For all their violence, supervolcanoes also give. Their eruptions shape climate. Their ash enriches soil. Their minerals power technology, destruction, and renewal. That is their rhythm. You float back now. Above the glowing map. Yellowstone, Toba, Taupo, Margarita, Campi Flegrei, afar. Galen, each one a pulse, each one part of the planet's great dreaming. They are not evil. They are not angry. They are not waiting to punish. They simply are. And understanding them is not about fear. It's about humility. It's about learning to live in tune with a restless, ancient world. As we drift toward the next chapter, the question changes. Not, where are they? But, what would it mean to witness one awaken? What would we do on the day the sky begins to shift? When the signs come, will we recognize the story they tell? Will we remember how to listen? You're floating again above the sleeping earth, where clouds drift like thoughts and mountains breathe slowly beneath their veils of time. Somewhere below, beneath your stillness, a magma chamber stretches and shifts. It does not roar, it does not rage, but it moves. And movement on this planet is never meaningless. The world has always spoken in signs. The challenge, the burden, is learning how to listen. This is the chapter of quiet instruments, of careful math, of watching shadows move and asking, what comes next? Prediction is not prophecy. It is not crystal balls, nor visions in the fire. Prediction is patience. It is built of numbers, of sensors buried in soil, of satellites turning silently overhead. It is a science of uncertainty. And in that uncertainty is where the courage lives. Begin with the earth itself. When pressure builds, deep below, the crust responds. It swells. It cracks. It quivers. These movements are measured by seismometers, devices that can hear the faintest tremble in the planet's skin. One quake may mean little, but a swarm, a sudden burst of dozens or hundreds of tiny shakes, might suggest magma is on the move. Not all swarms end in eruption, but they are whispers we cannot ignore. Now look at the land. Satellites with radar can detect ground uplift, changes in elevation, as small as a few millimeters. If the ground is bulging, gently rising like dough, it might mean magma is pressing upward, pushing the crust like breath into a balloon. Yellowstone rises and falls in slow rhythms, sometimes for years, like a sleeping chest, lifting with unseen breath. We measure, we chart, we wonder. Then there is the air. Volcanoes speak through gases. As magma nears the surface, it releases carbon dioxide, sulfur dioxide, water vapor. These can be detected by sensors on the ground or sniffed by drones circling through volcanic skies. A change in gas composition can signal that magma is heating, evolving, rising. The earth begins to exhale before it speaks. And still, these signals alone are not enough. One must learn to read them together like lines of poetry. each word incomplete without its neighbor. Seismic swarms plus ground uplift plus gas changes. These build the narrative scientists call unrest. And unrest does not always mean eruption. It may mean movement, adjustment, rearrangement. So we watch and we wait. In places like Yellowstone, Toba, Taupo, and Campi Flegrei, monitoring teams work quietly every day. They do not make headlines. They don't shout unless the signals do. They are keepers of long stories, watchers of graphs, listeners of ground tremors, guardians of probability. Their tools grow more precise each year, but the truth remains. We cannot predict with perfect certainty. We can say something might happen. Here's the likelihood. Here's the time window. But not when or how big or for sure. There keeps her secrets in layers of molten ink. And so prediction is also communication. How do you tell the public there is a chance, but not a certainty? How do you balance preparedness without panic? This is the science of warning systems, of color-coded alerts, of threshold decisions. Too early, and trust erodes. Too late, and the cost may be lives. This is why volcanologists walk a tightrope between caution and urgency. History offers reminders. In 1985, Colombia's Nevado del Ruiz erupted unexpectedly. Warnings were issued, but they were delayed, muted, lost in translation between science and politics. The result was a tragedy. Over 23,000 lives lost in a sudden lahar that swept away the town of Armero. And yet, the signs were there. Prediction is only half the work. The other half is making it heard. On the other end of that spectrum, Iceland, a country born from volcanic breath, their monitoring is woven into daily life. In 2010, Eyjafjallajökull erupted, a modest eruption, but its ash halted flights across Europe. Though no one died, it was a wake-up call. It showed how even small eruptions can ripple through modern civilization. Since then, satellite networks, international volcano observatories, and rapid response models have grown stronger. We learn from fire. We adapt in its glow. But what of the giants? What of the supervolcanoes that sleep for tens or hundreds of thousands of years? Their signals may stretch across centuries. The patterns are harder to parse because we've never witnessed a super eruption in human history. We can only simulate, model, compare to ancient deposits. We can dig cores from lake beds, measure ash layers, read the chemistry of old explosions. But this is like predicting a heartbeat from the outline of a fossil. Still, we try. Because to try is to care. In recent years, AI and machine learning have begun to comb through volcano data. These tools can spot hidden patterns, subtle correlations across decades of sensor readings. They are not infallible, but they offer a new kind of ear, a way to listen not only with attention, but with pattern recognition beyond human scale. Perhaps someday they will help us read the signs before the silence breaks. As you lie here, listening to the breath of the world, you are part of this unfolding story. Your time, your technology, your questions, they are part of humanity's effort to live wisely on this restless earth. Prediction will never be perfect, but each sensor, each observation, each careful voice brings us closer, not to control nature, but to understand her, to coexist, to prepare, to respect what sleeps beneath. And now, as this chapter softens, another rises in thought. What if a supervolcano did awaken tomorrow or next year? What would happen in the days after the ash begins to fall? What would we feel? See, remember what happens after the first blast? The air is still tonight, but somewhere in the folds of the earth, heat rises like a secret. And you lie quiet, breathing slowly, wondering how a world prepares for the unthinkable. Supervolcanoes do not roar often. Their silence is long, long enough for cities to rise, for empires to fall, for stars to be mapped, and seeds to be stored. But time is not a promise. It is an invitation. And so, while the giants sleep, humanity, tentative, thoughtful, a little afraid, prepares, not with loud alarms, but with quiet systems, with planning, with patience, with hope that stretches beyond the lifetime of any one voice. Let's begin with the places that watch. Volcano observatories, perched near sleeping giants, are always awake. In the U.S., the Yellowstone Volcano Observatory gathers data daily: seismic swarms, ground swelling, gas emissions. Nothing spectacular, but it is the absence of change that matters most. The stillness, the patterns, the way magma whispers before it climbs. Around the world, in Indonesia, New Zealand, Italy, Chile, scientists monitor ancient calderas, gathering clues like archaeologists of the future. They do not expect fire tomorrow, but they prepare for it, just in case. Governments prepare too, but quietly, because supervolcanoes live in the shadowland of low probability, high consequence events. Most people have never heard of VI7 or VI8. They've never studied what 1,000 cubic kilometers of ash and gas could do to the air, to the crops, to the trade routes, and the sky. And that's all right. Not all fears need to live in the open. So planning happens in soft places: civil defense agencies, resilience councils, international science groups meeting in quiet rooms to ask, what would we do if the sky darkened? The answer begins with food. For after the ash comes the cold, and after the cold comes the hunger. A super eruption might not destroy a city, but it could collapse a season. Sulfur aerosols, lofted high into the stratosphere, reflect sunlight, cooling the earth for years. The crops don't grow, the harvests fail, the rains change. This is not speculation, it's memory. In 1815, Mount Tambora erupted in Indonesia. The next year, 1816, was called the year without a summer across Europe and North America. Frost in July, snow in June, famine, migration, and whispered prayers over empty fields. So today, some scientists and governments quietly study alternative food systems, ways to feed billions if the sun withdraws for a season or more. Algae in bioreactors, mushrooms in the dark, cell-based proteins grown indoors, even bacteria engineered to thrive in low light and high ash conditions. It may sound strange, but so would the sky, turning gray for 3 years. This isn't fear. This is foresight. Then there's the question of mobility. Ash, when dry, drifts like flour. When wet, it clogs lungs, collapses roofs, stops engines. After a major eruption, entire regions may become impassable. Airports close. Highways vanish beneath gray dunes. Solar panels fail. Water sources become choked. So disaster plans include rerouted supply chains, alternate air routes, portable filtration systems, pre-staged emergency shelters built far from known calderas. Some regions even practice volcanic evacuation drills, not for a local cone, but for fallout from eruptions halfway around the globe. Because ash respects no borders. It travels with the wind, crossing oceans like a memory carried in the sky. Now imagine the digital realm. What happens when communication towers are coated in ash? When satellites blink through charged dust? When power grids falter under sudden demand? Here, too, preparation hums quietly. Data centers install filtration. Emergency networks rehearse switching to radio, to mesh networks, to low-frequency bands that travel far with little power. Governments build redundancies, backup servers, stored maps, pre-recorded instructions to be released if systems fail. The world is becoming more connected and therefore more vulnerable, but it is also becoming more aware. And in that awareness lies resilience. Then there is the challenge of coordination. No country can face a super eruption alone. That is why the scientific community has slowly built a web of cooperation, the Global Volcano Model, the International Association of Volcanology, disaster risk networks, and resilience frameworks woven through the United Nations. These are not headlines. They are handshakes, emails, shared protocols, common maps in many languages. If Yellowstone ever stirred, or Toba, or Taupo, the response would be global. Scientists would share data. Governments would align resources. Evacuations would span borders. Food shipments would cross oceans, like aid during war. Because we now know that a supervolcano is not a local event. It is planetary. And so, the response must be planetary too. But amid all this science, all this modeling, all these plans and meetings and white papers, what about the human soul? How do we prepare ourselves for a disruption so vast it rewrites the rhythm of the sky? Here, the quietest preparations may be the most profound. Communities learn to talk gently about risk. Schools teach not just equations, but adaptability, how to pivot, how to care for others in crisis. Religions and philosophies grapple with uncertainty, offering meaning in the face of nature's grandeur. And you listen, you learn, you imagine. That, too, is preparation. We will never stop the next eruption. We cannot hold the crust in place with technology or hope, but we can meet it with readiness, with compassion, with wisdom drawn from deep time and quiet study, in bunkers and seed vaults, in greenhouses and policy rooms, on mountaintops and classroom chalkboards. We are preparing, not because we are certain, but because we care, because we belong to this earth, even when she shifts beneath us. And now, as this chapter exhales, you may wonder something else. What happens to life after such an event? Not just humans, but animals, forests, oceans. Does life retreat or begin again? Does the earth forget or remember in green? Let's go there next, to the world after ash. The earth is not still, even when it feels silent beneath your feet. It rises and sinks like a sleeping chest, inhaling, exhaling, its breath long and slow, etched in centuries, echoing in stone. You live on this breath, though you rarely feel it. You walk the skin of a planet that moves, a surface stretched over tides of fire and time. It is easy to forget this. When days feel ordinary and skies are calm, the ground feels dependable, a solid promise under your shoes. But Earth has moods, not anger, not cruelty, just rhythms older than memory, older than names. And in those rhythms, sometimes, she exhales too deeply. A supervolcano's breath is one such exhale. After the blast, when ash has fallen, like gray snow, for weeks, when the light dims and crops shiver under a cold midsummer sun, life does not end. It changes. Let us follow it. Let us see what the earth does after her breath has paused and her voice, in fire and ash, has gone quiet again. The first to return are the quiet things, lichens, mosses, tiny microbes that chew stone into soil. They arrive like whispers, greening the gray, softening the broken lands. They do not need much, just rock and time, just a foothold. And from their work, a cradle forms. In the new ash beds, minerals bloom, nutrients once buried deep in magma, now scattered like a gift across the landscape. Soil, strange and fertile, begins to form, and life follows, as it always does, with courage and patience. Grasses come next, then wildflowers, then trees that dare to root in still warm earth. Birds pass overhead and sometimes pause. Seeds fall in silence. Winds carry pollen to places that wait, and slowly, in years and decades, a scar becomes a meadow, then a forest, then a place so full of song you'd never guess what lies beneath. Even here, even on ground, once torn by flame, the breath of the earth settles again into rhythm. You are part of that rhythm. You, with your bones made of calcium from ancient ocean creatures. You, with your breath tuned to the oxygen trees exhale. You live in the middle of deep time, between eruptions, between seasons, between the heartbeats, a planet still dreaming. To know that supervolcanoes exist is not to live in fear. It is to understand the great story you are in. Because the same forces that can darken the sky for years also shape the lands where your food grows. The same fires that once cracked the earth also birthed the continents beneath your feet. Creation and destruction are not enemies here, they are companions. And you, fragile yet brilliant, have learned to read the signs in stone, to watch the ground's quiet signals, to whisper back with science, with listening, with preparation. You do not control the earth, but you do live with it. You adapt, you study, you plant your gardens on lava's bones. You write stories in ash, build cities on calderas, dream futures, even under uncertain skies. And still, you listen to the rumble beneath, to the silence that precedes the shifting of plates, to the data, the memory, the science passed, like lanterns from one generation to the next. No one knows exactly when the next breath will deepen, when the pressure below will rise beyond quiet. But we are no longer blind. We have sensors that feel what you cannot. We have eyes that peer inside mountains. We have minds that connect patterns across centuries. And we have each other, a species that watches and wonders and cares. There is comfort in this, not certainty, but preparation, not control, but respect for this world and its wild rhythms, its ancient temperaments, its slow dance of ash and bloom. You live on a breathing planet, one that remembers, one that remakes, one that rests, then stirs, then sings again, in fire and light. And in your quiet moments, you feel it, the deep hum beneath all things, the pulse that shaped oceans, the whisper in rock. You are not separate from the story of the earth. You are a note in its symphony. You are a breath in its long exhale. You are a listener in its dreaming silence. And as you drift now into your own soft night, somewhere deep below, the planet turns again. Its warmth steady, its memory long, its heart still beating. Hi there. You've walked with me through ancient eruptions, through buried breaths and simmering ground, through the hush of ashfall and the patience of earth. Together, we've explored a planet that sleeps and stirs, that holds its secrets in stone and its wisdom in heat and pressure and time. You've listened to the heartbeat beneath mountains, to the science written in silence, to the stories that rocks remember. And now, as this final chapter closes, I just want to say, thank you. Thank you for letting curiosity guide you. Thank you for resting your mind in the rhythm of science and story. Wherever you are, beneath whatever sky you sleep, know that you are part of something vast and beautiful and still becoming. So breathe in deeply, let it go slowly, and trust that the earth turns gently beneath your dreams. Until next time, this has been the Dreamy Physicist. Good night.